Okay, it's done. So now I have 45 gigabytes. I'll press record. All right. So we should be good now. Okay. So I'm recording again. Oh, I forgot I should have not. This is going to record over what I'm. I'm going to change this to. It doesn't actually start until you press stop. So as long as I change, it'll. Okay. There. All right. So what we're going to do now is implement the time step. And to do this, what I'm going to do is create a new model. So I go in here, I say new model, and I'm going to put my model into the new model. I think that's the easiest way to do it. You could put the things I'm going to put into this model into the growth cycle model, but if you do it this way, what we're going to do eventually is move this growth cycle into here. So it'll just be a single little thing. The whole growth cycle will just be one thing inside of this model, which I'm going to call temporal growth or something. Temporal growth. I'm going to copy that. I'm going to close this down, say yes, because that's what it always does. I'm going to change the name of it right here. Paste. There we go. Now I'm going to edit it. Now it says temporal growth up there, just so that it gets there. Temporal growth. Before I move the growth cycle in there, I'm going to show you the thing that we need to add to get it to work. Okay? If you right-click anywhere inside of this white part, you can say that you want to do. There are a few things on here. We're going to use create variable at least once. We're going to use iterators. Okay, iterators are things that will allow you to cycle over a bunch of different things. Okay? The most basic one, most straightforward one, is just the for loop. It's kind of like programming. We have another class where we get into programming more. We're going to learn some programming concepts, basically. We're just going to put them on this flat, this model. Okay? We're going to use the for loop. The for loop allows us to go from one value to another value, a numerical value, by a certain step. Okay? The while loop in programming, it just keeps going until something is false. Right? Feature selection will go down a bunch of features, and it will select one feature at a time. So you could create a model. Doesn't do much good for what we're talking about, but you could create a model that selects a feature, then runs the model, selects a different feature, runs the model, selects a different feature, runs the model, all the way down. You could do row selection, which is kind of like feature selection, but it works on a table. And these other things, different data sets, different feature classes, different files, they would run. You might think, we probably could get this to work by selecting rasters. The problem is, it's just going to select all the rasters, and it's going to go through every raster and do something in it. So you probably think we could use that for what we're doing. The problem is, we needed to pull two rasters at the same time, not one raster each time through. We need to pull two, and so it's actually easier to use the for loop. So let's stick for loop on there. We're going to do for. So now we have an iterator. And if we double click on it, it's going to give us the from value and the to value. Okay? And the by value. We want this to run for 1 year. And we want it to start in June. And so our from value, what's that? It's going to be 6. Yep. I couldn't hear. Sorry. I'm making a weird face. 6. What? No, I was like, what? Not no. 6 to, what's that? To 5. Well, this has to be in order. So we need to go 12 past 6. So 6, 7, 8, 9, 10, 11, 12, yeah, 18. Somebody on the coast said it. So 6 to 18. All right, by 1. Okay, now, we say okay. One thing that we could do is actually make those model parameters. So we can make variable from parameter from value, make variable from parameter to value, so that it'll actually go from and to. Oh, we're too fast, right? Right click on the for loop and say make variable from parameter and then choose from and to. Right. And then if I right click on the word from, if I right click on it and say model parameter, I can click on to and make that a model parameter. So this will now go from this to this. All right. Something I just thought of. Maybe it's not good to bring in things that I just thought of, but. Yeah, well, something I just thought of is actually, this is something I was going to do. Okay? From to, why did I do that? Now if I save this, if I close this and save this and I run it from here, the reason I did that is now those appear there. So I could change this to start month. Okay? I could change from value to start month. Now to value, the problem is that the to value doesn't make as much sense because you have to. It's not the end of month, because there's no 18th month. It's the thing. So anyway, what I was thinking, actually, let me put in what I was thinking a little bit later after we get past another concept. Okay. So this out month, I mean this value right here is going to go 6. The next time through, it's going to be 7, 8, 9, 10, 11. In fact, we can go ahead and run this and say okay, and it actually shows us all of the outputs that it ran. So it ran it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why did it run it that many times? Is 18 not the right number? 6, 7, 8, 9. Oh, because it included 6 and 18. So we did 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Still seems like it's running one more time than it should. In any case, it's running, but and we can see how many times it's running. Okay. It's running, and it looks like it's running one time extra. We'll be able to debug that in a second, or figure out why it's doing that in a second. So we've got our from and our to value. Each time it's creating this value. We're not seeing what that value is, okay? But what is that value? First time through it's 6, second time through it's 7. It does get to 12, then 13, then 14, then 15, then 16, then 17. That's a problem because we don't have a 17th month, right? So I'm gonna tell you how to fix that. Starts recording. Okay. There's another tool in here called model under model-only tools, there are a bunch of tools. You could go ahead and read about all these tools later. But we're going to use calculate value. What that allows you to do is to calculate a value based on the variables that already appear on the page. So what we're going to do is use that to turn the value 13 back into the value 1, and the value 14 into the value 2. Okay? All right. So calculate value goes right here. If you click on it, what you can do is enter an expression. I don't know if you remember, but a few weeks ago, I told you that you can refer to any other value on here as percent, the name of the variable, which I'm going to make sure, just a second, I'm going to make sure what it's called. It's called value. So we can refer to any value as percent value percent. So now that value will always be, every time through the loop, that'll get a different value. The first time through the loop, that'll be 6. That'll be 7. And we're gonna do some formula that will change 7, or not 7, 13 into 1, and 14 into 2. And it'll also change 25 into 1, and 26 into 1, and 2, and so on. Okay? Now, I don't expect you, but maybe for those of you taking computer science class, what's a formula that can do that? If we only were going to do up to 1 more year, which on the lab it would work, we could simply do subtraction, right? So we could always just say value minus 12. Well, that wouldn't work though, would it? Because with 6 minus 12, we get negative. Yes, we could do an if statement. That's what this is for. So we could say if value is greater than 12, then do this. If it's not, do this. Right? Okay. Well, this is how we can create a general one without a big line, a big true-false statement. I guess it's not even a big true-false statement. There's an operator, add, subtract, multiply, and divide. They're all operators. There's an operator that actually will give us the remainder using integer division. So 12 divided by 12, the remainder is 0, right? What's 12 divided by 13? 1 with 1 remainder. And it only gives us the remainder. So this mod operator, which in most computer programming languages is a percent. It will always produce the remainder, even if the division is 0. So in other words, 12 divided by 6 is 0. It doesn't fit in. And there's 6 remaining. Okay? All right. So let's see. Yeah. So this is going to work. We're going to have to go back and change things. So what we do is we say value divided by 12, and it's really plus 1 because we can't have, no wait, because 12 is so when it gets to 12, it really needs to equal 12, right? And when it gets to 13, it needs to equal 1. And when it gets to 11, it needs to be 11. 14 needs to be 2. Okay. So really, could, but when you get to 24, I mean, you're right, for this it would work just fine. For 1 year. So I was trying to make a more general case, but you're exactly right. But for this, so 11, or 12 mod 11 is equal to 1. I mean, is equal to 11. 12 mod 12 is equal to 12. I mean, sorry, is equal to 0. So in any case, we do have to do an if statement, because if it's equal to 0, we need to change it to 12, right? Okay. I was trying to get away without having to do an if statement. We can't do it. Let's go ahead and look at what this does, though, okay? We'll just enter this in for now. Percent value, percent 12. That means that it's going to be the value mod 12. And now it's going to actually show us those values when we run it through the expression, when we run the tool. One thing that we want to do is to establish that this needs to happen before this. So in ArcGIS, the way you do that is just make the connection like this and say that it's a precondition. So what you're doing is just saying, this needs to run before this. So now that'll work. Then save it, and we're going to try to run it. So now, as it runs, it tells us the value. So the first time through it equals 6, then 7, then 8, then 9, then 10, then 11, and then at 12 it equals 0, but at 13 it equals 1. At 14 it equals 2, 3, 4, and it keeps going up, right? So it's actually perfect except for 12. 12 is the only time it's not right. See what I'm saying? If the value is 0, it needs to equal 12. I'm not making sense? What's that? You see how it's calculating the value each time through the loop? So it's calculating value equal to 6, values equal to 7, because value mod, so 12 mod 6 is equal to 6. 12 mod 7 is equal to 7. And so on. 8, 9, 10. But 12 mod 12 right here is equal to 0. So we're going to have to put in an if statement. Say if we get 0, we need it to be 12. The other thing we could do is rename 12 to 0. But that doesn't seem right. Mod 11. Okay. So this works great. The other thing I forgot to say, I don't know if this matters or not, but I like to take and tell. So click on this green 0 and say properties, and under data type. Oh, it makes it, so it's okay. Maybe it's this one. Yes. So click back on calculator, and under data type, change that to string. It's going to produce a string each time. In other words, it's going to produce text. The reason why is because this is going to become part of our file name. We don't have to do any conversion later on. It's going to produce that as a value. All right, so we are going to have to do a code block. I hope to not do that. So it's a little bit might be a little bit computer science-y, but we're going to do a little code block here. We're going to have an if-then statement. Okay. There is some help. If you hit help, you can go down here and here's some examples. I'll make this a little bit bigger. Here's some examples where you can write a function, or you could just say create a variable. All right. So yeah, there's a function. So basically, what happens is if your code can fit on one line, you can put it in here. If it can't, you need to put it down there. And so, so we could do something like, oh, and by the way, you can't put this percent value percent doesn't work inside here. This only accepts real Python code. So you actually have to do a function if you're going to try to feed in a value. So this is what you're going to have to do. So you go something like this. We'll just call it get, not right there. We're going to call it get month. Uppercase, lowercase does matter in this Python, in this language we're using. So you say get month, percent value, percent, and you put that in parentheses. So what you're doing is saying use this function, and we're going to put in to the function just the value, and then we're going to use the return keyword to give us the month. So we have to say def, def, get month, and then we have to say what the name of the variable is. You can't use percent value percent. You're going to have to just, I'm just going to call it n. N kind of makes sense because it's the number of times through the model. Okay? N is the number of times through the model. So I've got my def, get month, n, and I put a little colon after it. Right, the way Python works, I'll have to press enter, and I'm going to have to indent the next lines of code. And the indentation doesn't matter how much I indent, but I always have to keep the indentation consistent. It's hard for me to see with my eyes always a single space, so I'm going to type 2 spaces to indent the next line. All right? And then I'm just going to say out month equals n mod 12. Or no, 12 mod n. 12 mod n, like that. And then I'm going to hit enter, and I have to put 2 spaces in again. And then I'm going to say if out month equals equals 0. You have to do 2 equals. Oh, and I should put this in parentheses. If out month equals 0, parentheses around the out month. Then I have to put another colon. And then I hit enter. Now I'm going to have to put in 4 spaces because I have to indent even more for the if statement. 1, 2, 3, 4. And then I'm just going to put in out month equals 12. Right. Next semester, we're going to learn about Python, but this out month is going to produce the same thing that was produced up there. So it'll be 6, 7, 8, 9, 10. But for 12, it's going to produce a 0. So this line says if out month is equal to 0. In Python, there's a different operator that's used to set a value equal to 0 than there is to compare a value to 0. So this is comparison. If it's 0, do this. Set it equal to 12. Right? And then finally, the last thing we need to do, 2 spaces this time, is to return out month. Make sure, like if you capitalized O or you capitalized M anywhere, it needs to be the same. So this is a variable, and it's going to be returned out to that. All right. So once it looks like that, you're all set. You can hit OK. Now I'm going to save it. And now I'm going to run it again. Says syntax error. Okay, let's look and see if mine calculate value. Okay, value 12, 5, 4, 3, 2, 1, 12. Mine didn't work. 12, 12, 12, 12. What's that? Python isn't, there's no declaring variables. All right. Has anybody got a syntax error? No, so if you're parentheses no. So I know it's hard to see, but I'll blow it up. But the parentheses only around out month equal to 0. If is not capital, the I is not capitalized. Yeah, you can turn it down. I'm going to make it bigger, but it didn't work, so I got to modify it a bit anyway. But value mod. You don't have to do this for now. I'm going to get the formula working right here. Yeah, that's the first thing I was going to check. Yeah, I mean mine works, but it doesn't produce the right values. Because that would make sense. 6, 7, 8, 9, 10, 11, 12, 1, 2. Yep. So that was right. I just had these two reversed. So what I'm going to do real quick is I'm going to put this into Notepad. Is there space there? No. All right, there we go. I made that bigger. Okay, so now everybody can see it. It'll be bigger on the video itself. All right, so it needs to look just like that. If you type that in and you still get an error, the problem is probably that you didn't put in this one correctly right here. Okay. It works. Anybody else still having problems? Okay. So how about down there? Anybody's not working down there, or is everybody's working down there? I'm good. Okay. All right. So, yeah, so that's a little computer science-y, so good thing we worked through it all together. It's there. Okay. I'm going to say okay. Now, when I say model, run entire model, it's producing this value that gets produced is 6. Okay? I'm going to go ahead and change the name of this variable. I'm going to rename it. I can't rename it. How do I rename it? Rename right there. I'm going to rename that month. M-O-N-T-H. You can capitalize or not, but you need to remember to keep it consistent if you do. So that will always be the month. Okay? Now, this will always be the number of times through the model. So you're going to see that we're actually going to need both this value and this value. Because when we save the outputs, we have to save the outputs as 6, 7, 8, 9, 10, 11, 12, and we need to save it as 13 because if we saved it as output 1 and we ran it for more than a year, we'd be writing over the model as we created it. So we need both of these values, this value and this value. I think that we can actually, no. Okay. All right. Now, we have this all set up so we can just drag on growth cycle. But now I'm going to get to that part where I was like, hey, I have an idea. So now that you can see what calculate values does, what we could do is actually right click on this one and not make it a model parameter. And create another calculate value. Where's the model only tool is calculate value. Okay, then what we're going to do is create another variable, and we're going to make this what we call a long integer. And we're going to call this guy, instead of long, we're going to rename it. It's a long integer. We're going to rename this guy duration. Is that how you spell duration? Like that? Okay, we're going to rename that guy duration. And then we're going to make him a model parameter, and we're going to start with, and we're going to double click into it and give him a value of 12 to start off with. Okay. Now we're going to go into calculate, and this one we don't need to do a fancy code block. We're going to, one thing I'm going to do is change this from. I'm going to rename it start month, like that. I did a camel case. I did the S and M, the first letter of each variable capital. I don't like putting spaces into variable names. So I've got my start month and my duration. Okay. And I'm going to go into calculate, and the expression is going to be percent start month percent plus percent duration percent. So what I'm doing is I'm taking the start month and I'm adding the duration to it. So that when I run the model in the future, I don't have to think about what's 12 months in the future. So I'm just saying, okay, I want to start in June and I want to run it for 12 months. Or I could put in 36 months. Or I could put in 48 months. And it would just say, okay, that's going to run for 4 years. Or, yeah, 4 years. Okay. All right. So I'm going to put the 2 value. Oh. This output value is going to be the 2 value. Let's see if I can just connect them. Yep, we can only connect a variable to a process. So what I need to do is change the 2 value, and instead of writing 18, well, here, let's rename this one first. So output value, I'm going to rename it to end month. And then I'm going to change this in the 2 value. I'm going to double click and say percent end month percent. Now, I didn't do this beforehand, as I said, so hopefully it works. But, you know, that doesn't work. It doesn't let me put in that value. It doesn't say percent end month percent. Oh, I got a better idea. So okay, so that's a byproduct of how I did it. What I'm going to do right here is delete this. I don't even need it anymore. And under the for loop, open this back up, and then choose end month right there. Okay. So I did it. I mean, I knew how to do that, but I was trying to get. I did it wrong. Okay. So from start month to end month. And now it runs like that. So you'll specify a start month and a duration, and it will actually calculate the end month for you. What end month number that is. You don't have to do what I just did, but I just thought it was a little more elegant solution. So now if I save this and run the entire model, I'll get the same, I should get the same result. 6, 18, why am I getting 18? Oh, because it's showing me both values. So both calculated values are, so this is the calculating value for the end month. The end month is always the same value. Well, the 18, this is always going to be the same value, but for some reason it's calculating it through each iteration. And it's fine. We only need that value once. It's showing us both of those values, though, each time through the loop. This value always stays at 18. This value changes each time through the loop. Okay, I'm going to lay it out better. Whoops. There we go. So these are the two input parameters. All we've done so far is set up and get ready for a loop, a loop-de-loop. Okay? The loop is going to go from 6 to 18, but it's calculating 18 manually because you put in 12 here. Now we need to put the growth cycle onto the temporal growth map. So that's the next thing that we need to do. Whoop. So we put the growth cycle, we just drag it on there. And really there's only one thing that well, no, there's not one. There's more than one thing. But there's a few things that we need to do to make this work. if temperature and precipitation were going to stay the same, there would be only one thing. So what we need to do is, there's three parameters to this. In fact, if you double click on this growth cycle, you'll see those three parameters. There's three input parameters. There's temperature, precipitation, and source. We need to make those variables in our model. So what we need to do is make these variables. So we say make variable from parameter temperature. And then we right click and say make variable from parameter precipitation. I'm going to separate these out a little bit so that they all show up. Temperature, precipitation, and then finally make variable from parameter source. The source is going to be the source 4. I mean, not sorry, source 4. Source. The one that's called source. So we can go ahead and fill that in. Double click on it. Choose it. Actually, don't choose it from there. Choose it from the actual file on disk. I think it's better. So now you've got source chosen. If you want, you could make that a parameter so that, you know, if you wanted to make this model work anywhere, you could say, okay, let's introduce it in a different place than we introduced it last time. You can make this a model parameter. However, precipitation and temperature, those are just internal to the model. We're not letting people choose those. Those are part of the model. And so we need to choose the temperature of the precipitation data set based on these outputs. All right. So the way that we do that, I think the easiest way to do that is to double click and choose the file on disk. Don't choose the drop down. Choose the file on disk. Just choose one of them. It doesn't matter which one you choose. So for temperature, just choose one of the temperature ones. First one I see is that one. And then here, delete the number and type in %. What was the name of the variable? Month. %, month, %. So what we're doing here is, this is the path to your data. Temp, %, month, temp. Each time through the model, this is going to change into the month variable. So it'll be, start off 6, 7, 8, 9, 10, and so on. Okay? So we're going to leave that. And we're going to do it to precipitation as well. Double click. We're going to choose any precipitation value, any one that you want. I'm going to choose that one. It's just random. And do the same thing. %, month, %. It is case sensitive. Before I hit OK, I'm also going to copy this whole path. Copy all that. Copy. And then say OK. Then I'm going to go over to this new area and make sure that I save everything to the same directory I've been working in by pasting that in there. So I pasted that value. Alternatively, you could just go select another. You could go select it again. Like hit this guy, navigate to that place. I'm going to change precipitation though. I'm just going to call it out, not to get it confused with the other data sets I was creating before. So I just changed the word precip to out. So now I'll have out 1, out 2, out 3. The thing is that I don't want to use month anymore, because if I use month, I'm going to have that problem overwriting the last time it ran. So I have to change this to value. So that's going to be this one. So this one is always a number between 1 and 12. This number keeps going up. It's going to be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and so on. So that's why my output values should be values that go 1, 2, 3, 4, 5. I mean, sorry. Well, if I started with 1, they'd start with 1. But they're gonna go past 13 and keep going up. So they're named something that I have to. So when I see out 18, I know that it was the second year data. Okay. So it was the value for. It would still be. I'd still subtract 12. So it's the June of the next year, and out 19 is subtract 12. So when I get to 20 in the 20s, I would just do the same thing. Okay. Now we're almost done. There's a few things that we need to do. One is that we need to attach a month to growth cycle as a precondition. We want it to calculate the month before it calculates the growth cycle. So that needs to be a precondition. Otherwise, it won't run right. So it'll actually do this before it does that. Otherwise, these values wouldn't get there. Okay? The final thing that we need to do is attach this one to this one. And it will automatically make that a feedback loop. So if we attach this guy to this guy, and I got to move it around a little bit. But now if we hover over it, it tells us it's a feedback loop. So the second time, oh, I connected the wrong one, right? This is temperature, this is the out value. What do I need to connect the feedback loop to? So I gotta delete that. What's that? The new area is going to be what? Is it the new temperature, the new precipitation, or the new source? Yeah, it's the new source. So when it grows, doesn't it make sense that the next time, that's the source value where it's going to grow from the second time and grow from the third time. So I messed up. I just connect the out value to the source and just make sure it says feedback. I'm going to rename this. That's a long name. I'm just going to call this new area. I like that better. All right, now some of yours are probably going to fail, but we can look at that. I want to see if mine fails though first. Okay, I'm going to test it. So here I've got what I think it needs to look like, and I need to save it. And this one, because it's running the growth cycle model in here, and because of the quirkiness with the source being such a small raster, we need to run this, not from here, we need to run it from out there. So I close it. Now I'm going to run temporal growth. Go ahead and leave all the defaults because I set them up to work. The source is fine for now. And I'll hit OK. And hopefully I don't get any red text, right? But it will take a few minutes to run. So you can see how it's running. This is now 6. So it's running 6. Oh. Okay, sorry. Mine failed. Why did mine fail? I can see cell size is not set. I need to set those environments. That's the whole reason that we need to run it from there. So let's set it to temperature. Any temperature grid or any precipitation grid will work. And any cell size. So those three are what we need to set. Otherwise, it's going to fail. I'm going to run it again. Make sure that it works. Okay, so now it's running June again. It didn't get past June before because it was running June's stopped when it died. So now it's running, it's inside of the growth model. And it's running all the steps, see the divide, now it's running a condition, now it's running the float, now it's running cost distance. So it's running all those steps in the cost model. Once it gets past one step, we know that it's going to, well, we're pretty sure it's going to work. So now it's running the condition. Oh, now it's on 7. Okay? So now it's going to run that model again. So we didn't really save any computer time by creating. It's still going to take the same amount of time to actually run the model. The only time that we're saving is the time of pushing in all the buttons. So it's going to run. And I could have still made a mistake. So, but if I made a mistake, it's going to be in using the same month over and over. But we'll be able to see that because it won't have grown. So if I did the feedback right, it'll have grown correctly, and it'll finish up. If we were, what do you call it? If we were anxious, one thing we could do is open it up and load up out 6 and 7. You just can't load up any of the data sets that are in the middle of calculating, otherwise it'll screw it up. But I'm a little impatient, so we're going to see if we can. What are we on now? We're only on 8. So I'm going to open up 6 and 7 and see if it's actually growing. So now if I hit add data, I'm just going to add 6 and 7 because it looks like it's still working on 8. Yep. So see that guy? So there's 6, there's 7. Now, did we do 6 and 7 when we were doing it by hand? Those look a little different. We'll let it grow a little bit. Well, I mean that, okay, so 8's done now. So there's 8. Yeah, it's growing at some rate where it's different. See how that's different? Let's go look back. I'm going to close this up now. Yeah, let's go look back there. So it is using temperature 10. We can see that in this conditional operation. That's good. Mine says not responding. It's okay. It's still working. I'm going to close my other ArcMap so that it can give it some more resources back. Ooh. Okay. Make sure that it's using temperature 12, precip 12, precip 12, it's dividing precip 12. So it is using the right precipitation and the right temperature. And each time through. Out 12. So the next time through, though, it should be out 13. Yep, out 13, but still using temperature 1 and temperature precip 1. Yeah, it's on the first cycle that's in January of the next year. The output is 13, temp 1, precip 1. All right. Okay. So how did it go? Did yours still fail even? Model 12. Yours said completed? But did it even run? Like it ran a bunch of times? I wonder why mine's still running. It seems a little weird that yours would finish up. Did you try to load your outputs in? Okay, close it. Hit add data. And then look at add 6, 7, 8, 9. Turn off 9. Yeah, yours is working. And your computer's just working faster than mine. Turn off 8. You can change those to different colors if you want. See what I'm saying? See, those are the same. They should be. What's 7? Turn on 7. You know what? I wonder if we kept this. When we ran this black one, we kept the source the same. Or if we updated it, right? Geoprocessing. Go to geoprocessing results. Open it up and go all the way back to the first one. Let's go side down one thing. The problem is that we didn't update the source. So we didn't make 6 the source. So in other words, the way it's running in Model Builder is correct. We messed up. Well, that was correct. 7 is correct, but we should use output 6 as the source for the next time through. Okay. Both times we had it growing from the source. We didn't have it growing from the previous extent. What's that? You can't run it from there. So, say, you run it from the. But did you already run it once? It's never going to run from here. So hit add data. You can see add 6, 7, 8. That's 8 now. So it's growing. Those are the ones that just completed. So said that, and, oh, this why are you sorry?
Because I hate.
Might have a problem. Out 6 is open. Oh, we'll see. We'll see if it works. How about you have a problem? Yeah, they are. Okay. So everybody's is working, I think. How about on the coast? Okay, but did it's still going? That's a good sign. It means it's probably working.
It looks like my results look like yours.
Right. So William and I looked at this, and the output from the model matches at 6, but it doesn't match at 7. And that's because we actually did it right in the loop, but we didn't do it right when we pressed all the buttons, which actually presents or shows you another reason why it's actually better to do things, to automate things and get them to working using a machine rather than pressing all the buttons. Because if we go way back and look at this, we look at the results. So if I go way back to my growth cycle, when I ran 7, I forgot to update, so I made the output. I updated both of these, all 3 of these to 7, but I forgot to update the source, because the source is always the previous month's source. I could have also, mistyped something. So anyway, that's just another reason that automation is cool, because once you get it working, it's always going to produce the right. You don't have to worry about the computer forgetting to change the source for the next time through. So the reason that output 7 and out 7 look different. See, out 7 and output 7 look different. It's because out 7 was created automatically and it used 6 as the source. So it grew from 6. 7 only grew a little further past 6 because we made it start back at the source, but it rained a little more in July than it did in June. And so it grew a little further past. So anyway, so this is actually correct. So now we can look at the end of the model, which was 18, and that is the area that it grew after the model ended. So we could continue this through. I wouldn't suggest you do it now, especially if you're running off of a thumb drive. It's going to be running forever. All right. Okay. What all right. What was I going to say? Okay. Now we need to add in the last thing. Let's look back at the assignment, because that's what you're going to add in. Okay. So we modify the model so it loops through a specific starting point and ending month. We did that already. So part 3 of this lab will be to modify the model so that during each loop, a table is created that displays the total affected area for each state. So that's what you need to do. You need to add that in. You could add that into our model that we created, the second model, this So this one, edit. You can add that in here. So basically what you would do is this new area here would be the input along with the USA states to some sort of zonal statistics operation. Let's look in the spatial analyst model and look at zonal. And if we look at these different tools, we could use zonal statistics. Zonal statistics will give us it will give us some measurement. We could just use the zonal sum because all the values have a value of 1. So the zonal sum will be what? If I did the zonal sum and I have values of 1 and values of no data, the zonal sum will be the number of, what? Yeah, it'll be the number of pixels that have a 1 value. Because 1 plus 1 plus 1 plus 1 plus 1. And we could convert cells into area, right? We could do that. And that's perfectly acceptable. However, I wanted to introduce you to another tool. And you can use this tool. And it may actually make more or less sense. So go ahead and think about this. So here we have this tabulate areas tool. And what tabulate areas does is it's still a zonal tool. We have all of our zones, and then every unique value, it will tell us what the total is for that value. Okay, so it assumes that this is a categorical value instead of a continuous value. So the way to read this is that in zone 0, which could represent North Carolina, we have 3 10 values, 1 11 values, 1 12 value, and 0 13 values. Now we only have ones, right? So the way you're going to read this is North Carolina is going to have so many 1 values, South Carolina is going to have so many 1 values, North Carolina is going to have so many 1 values, and so on. That's going to be the number of pixels. Okay? Now, I do believe, maybe I'm not remembering this right. Oh, here, I'll just go look over here. I do believe that it actually reports it in air. Well, why don't we just run it real quick? I'm going to run it outside of this. So I'm going to choose the zone data. What's the zone data? The states, that's right. And then I'm going to choose the output for 18, so the final one. And then I'm going to use value as the class field. And then I'm just going to hit OK for now, because this is just an experiment. And then look at the result. Oh, I'm going to switch to list by source because it's only I don't think it's done yet either. It's still running. List by source allows me to see, it's a table. The result is going to be a table. It's just finishing up right now. Okay. So now I can open up that attribute table, and I'm only going to get states that have values. So here I've got 37 and 45. I need to go find out which states those are. And then, yeah, so this is actually reporting in, it's not reporting in cells, it's reporting in area. It's square meters. So see it's meters down there. So it's whatever units the data is in. So that's square meters. So if you wanted to figure out the percent, you would rejoin it to this table. And I think the best way to do this is to just recalculate that area field. Because right now this is in some other units. But if you recalculated that to square meters, you could just divide. Oh, here it is. This is in square meters. This one on this side. That's that one called shape area. So you could divide shape 37. State 37. I should have used name. Why don't I just do that? Oh look, but these are multi-part polygons. I messed up on that, didn't I? See how there's more than one for Florida, more than one for Mississippi, more than one for California. $150. Okay. So don't do this as part of your model, but let's. Sorry, that's not what I meant to do. All right, little vector lesson today. How do we remove or collapse every state that has the same value into itself, so that we only have one row for each state? Everybody remember that from the lecture I just gave in in 217. Dissolve. Dissolve is going to work. I mean, I'm sure there's another way to do it, but we're going to dissolve USA states, and we're going to dissolve it on state and name. It's under data management tools, generalized dissolve. So we're taking the states and we're going to allow them to be single part features. I should have used that when I made a few changes to the lab, and I screwed up. I should have given you states that were already dissolved. Okay. So make sure that create multi-part features is selected, because when you do that, it'll everything that has the same value for state and name will become one feature, even if they're not connected. Okay, let's go ahead and save this into the same place. We'll call it USA states underscore dissolve. Now, this does not affect the zones, because the zones, it doesn't really matter that the multi-parts, because it's a raster, so anything that's coded the same works. This only matters for your area calculation. So we don't have to rerun the other thing. Okay, save. Did I spell dissolve right? Yep. I put it in the same place. So now the result of this dissolve will only have 50 rows. See if we open this up. There are only 50 rows or 49 rows. Oh, because I left out Hawaii. It's not going to get to Hawaii. There's no way it's going to get there. In fact, I left out Alaska too, because it's not connected. And the reason that there's 49 is because the District of Columbia is there. So now these areas, shape areas, you can use to do the, you can join it back in with the state code and just do a division problem. Shape area, or it's the tabulated area divided by the shape area. All right, the last time I did this lab, I did not use tabulated areas, but I think it basically takes out a step to use it. So you're welcome to use it. I just used zonal statistics last time, but I noticed that as I was modifying the lab for this time. So tabulate areas. We'll do that. But you want to put it in your model so that it'll run for each step. So that during each loop, the table is created that displays the total affected area for each state. All right, the other thing that I did, because last time it took so long to run, we actually ran this 3 years. The last time that I taught this, and I knocked off 2 years to make it 1 year. The only problem is, we just ran it for 18 months, right? How many states did it get to? Let's move 18 up on top. So we just ran it for 2 years. And how many states does it get to in 1 year? It only gets to 2 states. And we see that in the tabulate areas result. Tabulate area. Because people were complaining last time that it took like 4 hours to run on some computers because you're running off of your portable hard drive. If you're running off of these computers, it doesn't take that long, right? So, anyway, it only gets to 2 states. In the lab, I tell you, I thought it would still get to a few more states, but I was wrong. So really, I'm going to leave the lab the way it is, but it really only gets North Carolina and South Carolina, so Tennessee and Virginia will be 0. So just ignore the fact that Tennessee and Virginia are on there. So each time through the loop, just a line chart showing how the affected area grows in North Carolina and South Carolina. And actually, I didn't actually say the percent. So just use the tabulated area. So if you want, you can output those files as DBFs and then import them into Excel and create a chart. It'll just be 12 points. And it'll show the area going up, show the area of North Carolina going up. Okay, then send me the model. So you're basically just going to add that tabulate area into the model right here. Edit. You can add it in right here. Tabulate area or zonal statistics, either one will get you the answer. If you do zonal statistics, you're going to have to calculate area as the cell size times the cell size times the number of cells. See what I mean? If you use tabulate area, it'll give you that tabulated area. So you'll have 2 steps to do or 1 step to do, depending on which tool you use. Now, when you put tabulate area on there, the raster, the import raster is just going to be connected from, this one's going to be what? USA states. This one's going to be, the zone field is always going to be the same. What's it going to be? State, or might be better to use name if you want the name to appear instead of a number. Either way, it doesn't matter. They're both unique. Import raster or feature class data, what's that going to be? That's going to be the new area. You can just drop down and choose new area. The class field is going to be value. That's the only thing it can be since it's a raster. The output table. What's the output table going to be? This is where you, if you don't do the percent value percent, you're going to not get, it's going to overwrite every time through the loop. So this needs to be some file path, table underscore percent value percent, because then it will always be called, table underscore 6, table underscore 7, table underscore 8, table underscore 9, and so on. If you just leave this the same path, it will keep writing over that, and you'll only get 18. that's another thing that you need to watch out for. Okay. We, I actually, that's what I was trying to say was that I messed up. You don't even really need to do the dissolve. You would have, you did need to do the dissolve before in order to get the, no, you never did need to do it. Yeah, so if you wanted to get percent area, you would have to do the dissolve. But you don't have to do it once. It wouldn't be part of the model. But I didn't ask for percent area, I asked for total area. But if you wanted percent area, you would do it. You'd do it. Just do it once. Okay. Anybody have any other general questions for the lab? Okay. Everybody's got a question. Before I do, these files get huge. They're much bigger than the Skype files. So I'm gonna pause.